So I'm in the Shure booth with Thomas Banks.
Hello.
And I guess we're going to talk about what's new for the show here this year.
Right. I've got two new microphones. They are DSLR condenser shotgun mics with integrated camera mounts. They're designed for the DSLR videographer community. First is have the VP83 or lens hopper, and it's a highly directional supercardioid condenser capsule. High sensitivity, low self noise. It's got a little shotgun interference tube on it. It is supercardioid. It goes low bar at 3 kilohertz. It's housed in a rugged metal body. It's got a exclusive Rycote shock mount. It's a premium shock mounting solution that'll never bend, snap, sag, or deform. It has one AA. It's powered on. It'll run for 130 hours on one AA. It has a 3-position gain switch with a 10 dB pad. It has a low-cut filter at 170 hertz.
Is there onboard monitoring for it or anything like that?
On this one, no. This is just a pass-through audio to the camera through the shoe. This guy is its big brother. This is the Lens Hopper VP83F. It has an on-off and a single-button record with a 5-position joystick. The single-button record records to a micro SD card. It can take up to 32 gig micro SD, on which it can record 60 hours of uncompressed wave at 24-bit 48K. It also has the same metal housing, RF immunity, high performance, low self-noise condenser capsule, exclusive Rycote shock mount, but it also has a camera out, 3-position camera out. You can damp it down to -40 or -20 dB depending on your camera sensitivity. And over here it has the monitoring headphone.
I guess, is there any disadvantage to sound quality having the onboard recorder and the monitoring, or do they sound virtually the same?
They have the same acoustic properties. Okay. This one just has an integrated onboard recorder to a high dynamic range preamp.
I guess now if you're outputting to the camera, that doesn't disable the onboard recorder?
Nope, you can do both.
Okay, awesome. MSRP?
We will announce the price when they're available this summer.
And then Canadian distribution, like they'll be available internationally?
Yes, they will be.
Excellent. Okay, so I'm in the Shure booth now with Gabe, who's a wireless specialist according to Thomas. I want to talk about the FP1 system.
Correct. Well, the FP wireless system was designed as a portable wireless system for cameras, and it consists of several different transmitter formats and a diversity receiver. And the whole idea of the line is that it's very inexpensive compared to our professional series like the UHFR. So the FP series is more prosumer, and the UHFR portable wireless is our pro top-of-the-line portable receiver.
The FP series was available like in the last year or so.
Correct.
UHFRs, were they available for the
It's been available a little bit previous than that. So they kind of came first UHFR, well, the UR5 portable receiver with the UR3 plug-on, and then follow up with the FP wireless. So they were about a year apart, maybe a little bit more.
So I guess Shure has a lot of experience on the wireless microphone side, or more
Correct.
Transmitters mounted on microphones. And then as opposed to right now, you're dealing with kind of also some body pack options as well.
Well, we have experience in receivers mounted in small formats because we use in-ear monitor systems.
Right.
So going off of that, we were able to just create a receiver in a portable format. And actually, if you look at the body pack of a P10R or a P9R receiver, and you look at the UR5 UHFR portable receiver, the mechanical design is actually the same. So where the antennas and the connectors and the jacks go is really what changes, but other than that, the mechanical dimensions are identical.
Let's take a look at some of the actual products.
Sure. So we can start with the FP5. The FP5 is based off the SLX wireless system, so it has 24 megahertz of spectrum available. You can get up to 12 channels to operate in a single band. There are several bands available that start from 470 megahertz and then end close to 696 or 698 megahertz. And the system is very, very easy to use. You have a scan, a sync, and an IR. So you do a scan, that's what you do to find a clean frequency. Then you you access the infrared eye on the transmitter, whether it's a body pack or a plug-on, and you put one in front. Well, this is an FP5, my bad. I need this guy. This is the transmitter. So what you do is you put the infrared eye of the receiver in front of the infrared eye of the transmitter, and then you hit the sync button, and you see the little red light flash. And that means that they are in sync. If I were to turn off this body pack, the blue light will turn off. That means that there's no more reception.
Okay.
So it's very easy to find a frequency, and because it's based off our SLX platform, it's a professional series, and it's designed to work in congested RF environments, which makes it very practical.
I'm seeing on this receiver that you've got 2 antennas. That doesn't mean it's dual channel though, is it?
No. 2 antennas does not mean dual channel. 2 antennas means that there are, well, it can mean different things depending on the design, but in our receiver, 2 antennas means that there are 2 points of reception, and they're separated from each other. So in the event that there's a dropout on one antenna, you have the other antenna as an option. So it's always best to go with 2 antennas that are properly tuned, that actually work as antennas. It's the most efficient way to receive and avoid any dropout points that can happen when either the transmitter or receiver are in motion. So the receiver includes a hot shoe mount. It includes 2 cables, one that ends with XLR and one that ends in a 3.5 millimeter, depending on what type of camera you plan to use.
Okay.
Following that, you have a body pack that you just saw.
Yeah.
It's very simple. There's no controls on it, and you just basically sync it to the receiver and it works.
Well, sir, before you continue, what kind of plug does this use for you?
All right, it's a good point to make. The connectors look very close. This is called a 3-pin male tiny QG, and this is called a 4-pin male tiny QG.
Okay.
And those are on the transmitter, the 4-pin tiny QG, that's the input.
Okay.
On the receiver, and this can be confusing because they look so similar.
Yeah.
The receiver, that 3-pin male tiny QG, is actually an output.
Okay. Why is it necessary to have different types of connectors for the input and the output?
Well, the 4-pin tiny QG goes back a long time. Shure's been doing wireless for many, many years, and back in the day, we used 4 pins. One was ground, one was 5 volts bias, one was audio, and then the 4th pin was typically used for lapel microphones. And remember that body pack transmitters, they're not only designed to work with mics. You can plug in a guitar, you can plug in a microphone for like a trumpet or a saxophone. So what we did back in the day was, in order to make the body pack work with both instruments and microphones that have different impedances, we use that 4th pin with the lapel microphones, and what we do is we would put a resistor across pin 4 and pin 3, which is audio, and that would bring the impedance down of the transmitter to something that the microphone itself, that the lav or the headset wanted to see. If you were to look at the pin configuration of a guitar cable, that resistor wasn't there. But as things started to advance in technology, we were able to, we didn't need that 4th pin anymore, but it was just, it would take a whole overhaul of microphones with old connectors with microphones with new connectors. So we just decided to keep the 4-pin, despite the fact that we don't use that extra 4th pin anymore.
Fair enough.
And on the body pack, we use the tiny QG because it fits, and we use 3 pins because it lines up easily with an XLR connector. So pin 1 to pin 1, pin 2 to pin 2, pin 3 to pin 3.
Right. Awesome.
So part of FP is the plug-on transmitter. This transmitter is very, very simple. It's very similar to the UR3 transmitter, but it has no LCD display, and rather than having buttons to pick up the gain, it has a potentiometer, and you can also sync the frequency via this crimson colored infrared sensor.
Okay.
So once
the same way as with the
correct.
body pack.
I don't think there's any batteries in here, but basically you turn it on, you sync it to the receiver, and it goes. Now you have 2 LEDs, and the design, the concept behind this design is that when you're adjusting gain, you need to be speaking into the microphone. And a lot of plug-ons have audio indicators on the side, so someone else has to speak while another person has to adjust the audio.
Okay.
This way, if you're working solo, you can adjust the audio yourself, and you can see how it comes into the transmitter.
Okay.
So you speak into the mic, you look at the LED, and you use the potentiometer to turn the signal accordingly. The other LED is a three-color LED for battery life.
Okay.
Now, another idea behind this is that it's ergonomic. Plug-on transmitters use the microphone as the antenna,
Yes.
and when they are rectangular in shape, they become uncomfortable to hold.
Okay.
So you typically go for the microphone. When you go for the microphone, you attenuate the RF transmission. It's basically touching the antenna, which in RF you don't want to do. So we designed this to be ergonomic and to be just very, very light, very efficient, and easy to use.
And designed to be held as opposed to holding one.
Right, it's basically a stripped down version of the UR3, but with the circuitry of an FP transmitter.
Also, phantom power? Does it provide phantom?
No, good point. It only works for dynamic microphones. Phantom power was one of the things we needed to remove to make it cost effective. And FP is less than half of what you would pay for a UHFR portable system. So it's very, very inexpensive. Doesn't mean it's cheap. It just means that it's very accessible in price. Now there's another form factor, the handheld transmitters. Run on AA's. And the battery life on these transmitters, they kind of go between 8 to 10 hours. Like the handheld and the body packs go 8 hours. The plug-on transmitter actually can run for 10 hours on AA's. And the microphones come with two capsules. You have the SM58, which is well known and doesn't need any introduction. And then the VP68, which is an omnidirectional microphone for interviews. This is a condenser microphone. Omni means it picks up sound in all directions, and you don't need to aim the microphone in order to pick up who you're interviewing. You can just place the microphone in the middle of 2 or 3 people and conduct an interview freely. So that summarizes FP. You can see FP in action here at this camera. We have the FE5 receiver on this right coat extension bar, mounted with a hot shoe, with a cold shoe, I'm sorry. And then you have the cable going into the camera. So this means that the camera input is coming from a wireless microphone, the audio going into the camera. However, we have this VP83F, and this is a mini shotgun that kind of serves two purposes. It can also serve as an external microphone into the camera, but in this case we have the wireless as our external mic. And the secondary purpose is that it can record to a micro SD card.
Actually, Thomas already talked about this.
Right, and that's why we have this in this configuration.
I was going to ask though too, and it's kind of funny, as a, I guess like just how I'm recording right now, I'm actually using a 2 mono to single stereo input. Like
you're using, I'm sorry?
I've just got a kind of a connector, it's a little Y splitter kind of thing. I'm running the lapel mic that I'm wearing to one channel, and the lapel mic you're wearing
to another channel.
Do you have any recommendations for or against doing something like that in a pinch?
Not necessarily. It really depends on how much work you want in post-production.
Okay.
At the end of the day, there's something that you can't change, and that's physics. So the microphone, the closer it is to the person you're recording, the better. So what you're doing of putting a lob on you is probably going to work better than depending on the microphone built into the camera. Also, the mics that are in the camera, sometimes they pick up the mechanical noise that happens when you use the zoom, and that's not desirable. So whether you're using a microphone like this that sits on the shoe and you're picking up at a certain distance, or whether you're using a lapel mic, they're just going to sound different. And the closer the microphone is to the person, the less ambient sound you're going to get. Right. So in post-production, anybody who's done post knows sometimes when a mic has way too much ambient sound, it takes a lot of work to kind of clean that up. Right. So it just depends on how you want to work after the sound is captured. Cool. Either way is good.
So we're back with Gabe at the Shure booth. We're going to talk about the UH.
It's called the UR5.
UR5, sorry.
That's okay. So I'm Gabe from Shure, Market Development Manager for Latin America. And here we got the UHFR version of the portable receiver. So what we have is the UR5, and imagine the UHFR receiver that's about rack size, compacted into a very portable camera mount format, as you can see here, and as you can see here. So, being that it's part of the UHFR line, naturally it's more expensive, but it has a lot of pro features. So let's go through them briefly one by one. RF wise, it occupies 60 megahertz at a time. So you can buy this receiver in different 60 megahertz bands, and in the United States there are 4 available. The idea of having such a wide tuning range is to always try to find a clean frequency, regardless if you're an environment with a lot of television activity, or if you're just in a high RF environment with a lot of mics and other activities going on. So let's say if you're going to go to cover a music festival, you're going to have mics and ears from everything that's on stage, plus the intercoms. You got to try to find something clean. When you use lesser expensive portable wireless systems, the tuning band isn't as wide, so your options are less. With UHFR, it's harder to have that happen. So audio, well, the system's an analog system, but it's very, very high quality. We use audio reference companion that makes the quiet sounds very quiet and the loud sounds dynamically rich. And the whole idea of audio reference companion is to make quiet and loud sounds sound very natural, because our analog wireless systems must compress audio in order to get the RF link from transmit to receive. The trick is to do that in a way that the ear doesn't perceive that there's compression, maintaining dynamic range, frequency response, etc., etc. So another big feature from the RF section is something called multi-transmitter mode. And multi-transmitter mode allows the receiver to swap from one frequency to the other rather quickly. So what I've done now is I scanned, and then I created a list of frequencies according to the scanned that it found. And the reason why you want to scan is because you want to look for something clean in the environment. And the reason why I created a list is so when I enter multi-transmitter mode, I have the list of those clean frequencies at a touch of a button. And I can see which frequency is available and which frequency is not available.
This is something like I remember, I guess I shouldn't mention these names, but I'm going to mention it anyway. So I guess in this entire system, I didn't, like on their entry, like their G3, Evolution G3 system, I don't think that this feature is there.
No, this feature isn't there.
Electrosonics though does have this kind of feature, I think.
I'm not familiar with what Electrosonics has as far as this feature is concerned. This idea actually came from Q mode in our in-ear systems. And the idea behind Q mode is for the monitor engineer to wear a pack, and then he can go from one in-ear mix to the other in-ear mix. Basically, he's changing frequencies from one transmitter to the other in order to not only hear the audio, but the RF link between transmitter and receiver, because sometimes RF noises can be perceived the RF noises, they're manifested as far as audio noise. So when you receive interference, it sounds a certain way. When you are in a null point and you have no reception, it sounds another way. But sometimes audio problems can sound like RF, but they're not. So the idea of having the RF link is for you to hear exactly what the musician's hearing if you're the monitor engineer. What we did is we just took that technology and moved it over to multi-transmitter mode. So if we pan back to the camera, to the receiver, you can see that like this channel, preset number 30, is kind of busy. It's got a little bit of RF activity, and that's not good, so I don't want to use that frequency. But channel 31, nah, not a good idea. Let me move down to, say, channel 28. That frequency is wide and clean. So if I were to take a UHFR transmitter, I can easily sync this frequency to that microphone, and voila, I'm operating. So let's just say for redundancy that I carry 2 mics. The reporter is using one microphone, and I have the other one as a spare on my hip using some type of belt clip. So if indeed the reporter starts getting hits and I'm surrounded by other reporters and there's no time to scan, I got like maybe 20 seconds to go on air, what I can do is I can move the camera and I can swap to the other frequency. I see that it's clean, and all I do is I just turn on the plug-on or the body pack, hand it over to the reporter. He changes the call sign on the mic, and he just rolls with it. So it's a very quick and easy way to do the mic swap. And mic swapping is done everywhere. You see it on stage. when a microphone needs to be swapped on stage, there's a guy dressed in black doing the roadie run, switches the microphone and runs back. Well, here you're doing the same thing, and multi-transmitter mode allows you to do that in a very effective and quick way. So that's RF. Another really cool feature is this rechargeable battery.
Okay.
Now, the rechargeable battery will give you 10 hours of runtime. Let's say you don't have a rechargeable battery, you can use AA's.
Okay, and without an adapter or anything, the battery just happens to, like your battery happens to slide into there. Okay.
The battery just happens to slide in there.
I guess
So-
just running off, say if I had a pair of nickel metal hydride AA's, like how long would that run for compared to?
It depends, because nickel metal hydrides, they have what's called memory loss. And what happens with nickel metal hydrides is that over time, using it, discharging and charging again, is not the only factor that makes the battery run less.
Right.
What happens is that there are changes in the chemical composition in the battery that makes it hold its charge for less time. So if you use a nickel metal hydride battery every day for several months, in maybe 6 months, the battery might not have a full 100% health. That means that when you charge the battery when it was new, it was giving you 8 hours. 6 months down the line, you charge the battery, and when it's fully charged, it gives you 3.
I mean, like, well, lithium ion still has kind of a problem. I mean, like, with oxidation.
Well, let me clear that up. Lithium ions don't have memory loss. The only thing that makes the lithium ion batteries last less over time are the cycles. And that also applies to nickel metal hydrides, but because they don't have memory loss, you can cycle lithium ion batteries time and time again, and they last a long time. And these batteries are medical grade. So if you go to a hospital and you look at a wireless baby monitor or a heart monitor, those devices have lithium ion batteries that are very, very reliable. That's the technology that we went with these batteries, which means that after 500 cycles, the battery loses 20% of health. So with a full charge, brand new, you get 10 hours with the UR5 receivers. 500 cycles have to go by before you can get 8 hours out of that battery. Another 500 cycles needs to go by before you get 6 hours out of the battery. So if you're using this every day, the battery can last you easily a year and a half to 2 years, depending on how long your shots are. So there's a microchip in the battery that memorizes the cyclage of the battery, and you can actually see that in the receiver. If you go in the battery menu, let me exit multi-transmitter mode. What I'm going to do is I'm going to go into system configurations, into the battery menu. There are 9 hours and 2 minutes left to use with the battery. The battery's been cycled 2 times, which means it's been charged and discharged 2 times since we've been here for 4 days, 3 days now.
Right.
The temperature of the battery is 78 degrees Fahrenheit, and the status of the battery is 92%. And it'll even give you the milliamp per hour of the charge.
Now, I guess just going back to this battery pack, it looks like it can physically fit inside the FP system.
It does not, unfortunately. No, it doesn't, because the FP is significantly thinner.
Oh, okay. So what batteries are in the FP system?
Just AA's, traditional AA's.
Okay. Oh, okay. So this happens to have a deeper one that happens to handle AA's as well.
Right.
As well as,
The design of the body pack allows us to use both formats, so the SB900 Shure battery or just traditional AA's. So we talked about RF, we talked about audio, we talked about the rechargeable battery. Another really cool feature about the receiver is that it uses 2 physical separate antennas, and these are external antennas. The difference between having a fixed antenna, fixed antennas are typically grounded on the inside, external antennas are grounded on the outside, and that's really what helps in assuring proper reception. And we don't have 1 antenna, we have 2 that are properly spaced.
in terms of external versus internal grounding, can you explain like why one is better than the other? Or how is it?
Well, to fully receive the complete transfer of power that you get from an RF signal, the antenna needs to be exposed in its entirety. So because the body pack is made out of metal, if you have part of the antenna outside and if you were to have part of the antenna on the inside, the antenna isn't completely exposed. So compare that to, say, miking a guitar cabinet. And if you put a microphone up against a guitar cabinet and you're right on the speaker, you're going to get one sound. But let's say you're a foot away, you may not get the sound you're looking for. But if it's practical to do that because of A or B reason, then you do it. With RF, it's the same thing. It's practical to keep the antenna. It has to be grounded on the inside if it's a fixed antenna, because you can't remove it. The moment we put a connector on the antenna, yes, it becomes more expensive, but the reception is better because the full antenna is exposed, so it'll capture the entire half of the waveform that it needs to pick up. So that's why external antennas generally are more efficient than internal antennas. So other things that the UR5 includes is this shoe mount, and because the shoe mount will keep keep the receiver in a horizontal position. Let's pan over to your left here. The shoe mount will keep the receiver in this direction, and typically with this setup, traditionally antennas will stay like that.
Right.
And if your microphone's in a vertical position and your receiver antenna is in a horizontal position, the antennas are not oriented in the proper. They're not oriented properly. So to properly aim an antenna, if the mic's vertical, the antenna received should be at vertical, or at least as much as possible. And that is why we also include these little right angle SMA connectors.
Okay.
So if you're using it like this, you use the SMA connectors and you stand the antennas up. If you are using an accessory that keeps the receiver in a vertical position, you can just stow those SMA connectors away and put the antennas straight up on the receiver. So it's a very stable, it's a very solid RF system. It works with all types of UR microphones. It works with the UR2 handheld. It works with the micro body pack. So let's say you want to do some type of shot where you're interviewing somebody, but you don't want them to know that you're wearing a mic. You can hide the micro body pack in the hair. You can hide it under your arm. You can hide it in a bra. You can hide the micro body pack. It's a very small body pack transmitter that works. Yeah, it's right over here.
Oh, that's small. Okay.
Yeah. So you can hide this in your clothing. You can hide this in a bag. You can hide this in a wig, and you can hide the lav microphone anywhere as well. It works with this. It'll also work with a 250 milliwatt transmitter, but to operate this you need a license, but from the FCC. Legally in the United States, you can only operate up to 50 milliwatts without a license. Beyond that, you need a license to be authorized by the FCC to operate a transmitter higher than 50 milliwatts in output power. So don't do that at home, kids.
Sounds good. Okay, Gabriel, this has been great. Thank you.
My pleasure.